Hello, and welcome to review for the big quiz that we're going to take over our confidence intervals and hypothesis testing. So this is the review for chapter 9, and I'm going to share my screen. Nope. There we go. Okay. So, first question says, the U.S. Census Bureau reported that the mean area of U.S. homes built in 2009 was 2,438 square feet. Assume that a simple random sample of 20 homes built in the last month had a mean square area of 2,514 square feet with a standard deviation of 225. Can you conclude that the mean area of homes built today is greater than that of the homes built in 2009? And here's our level of significance. So we're going to conduct the hypothesis test using a p-value method. This is dealing with means because they said the average mean area. So means and quantitative data. So we're talking about means. So our first step is to write out the hypothesis statement that we have. So they think that it was in 2009, 2,438. So the mean was equal to 2,438. But they are now questioning that they think the homes built today on average are greater than. So we're going to test as our alternative greater than 2,438. So this number is always the same. It's the historical number. And we use the population symbol, mu, and our alternative is greater than. The part where it says we took a sample of 20 homes and this was the information about the sample, that's our evidence that we're going to use in step 3. So step 2 is our level of significance, or alpha, which is 0.01. And our step 3 is our test statistic, which is going to come from our Desmos. Now, it is good to have open the page in our formula sheet packet so that you're getting familiar with that. This is going to go through the steps with you. So we did, we're doing a right-tailed, a greater than. This was our step 1. We did our step 2, and our step 3 is this test statistic here, which to write that out, on this one I'm going to, but we're going to use Desmos to come up with that for us by putting in the information. So the sample mean was 2,514, subtracting the historical 2,438, divided by the sample standard deviation of 225, divided by the square root of n and our 20 homes. And we're going to let Desmos calculate that. Then our step 4 is to draw our curve. And again, we're going to have this out in the open. It's the means, population mean, using a t-test, and we're going to just go along, and it's a right-tailed, so we're going straight down, and we're going to follow the right-tailed graph. So we're going to draw our p-value right here. And our p-value is going to be documented in step 5, and that's going to be that area right there. And we're going to compare that to our alpha from step 2. And then we're going to draw our conclusion in step 6. Okay, so this is where we're going to go to Desmos. So hopefully you've already saved these links in Desmos that I shared with you in Canvas. And so I'm going to go to my Desmos. And we are going to use the ones for means. It says means quantitative data. So it says enter the sample size, and ours was 20. Enter the sample mean, and that was 2,438. And then enter the sample standard deviation, and that was 225. And then we're testing that against the mean from the historical data, original 2,514. And then it gives us our T. And, oh, oops, I typed it in wrong. Sorry about that. Our 2000, oh geez. Our sample mean is, it should be greater than here. A positive 1.51. Oh, I've got this. Let's try that. I entered the wrong, this should be our sample mean up here. It was confused myself of what I typed in. And so this should be a positive 1.51 for our T. Sorry about that. And then you're going to go down, and I'm choosing the drop down for greater than because that is the test that we're doing. And then there is our p-value. So our p-value is 0.074. And then we are going to go back to our paper. So our p-value is 0.074, and that is greater than our alpha. So we do not reject J0. So there is not sufficient evidence to conclude, or you can say support the claim that new homes are more square feet than 2009. We don't quite have enough evidence. We're not far enough from the mean. So we do not reject a 0. That means we do not support the evidence to say that it's bigger than 2,438 square feet. Okay, so this is what these should all look like, something like this. Okay, problem number 2 says the 2008 General Social Survey asked 2,021 random people whether they owned a business or were self-employed, and 250 said that they did. Can you conclude that the percentage of people own a business or are self-employed is not 15%? Okay, so we're talking about percentages. So we're talking about proportions. And it's one sample. And so we're going to go to this page here, using the one sample. Regarding the population proportion for one sample. Okay. And so our first step is writing our hypothesis. And it says, can we conclude that the percentage that are self-employed is not 15%? So that's not, they're not arguing that it's bigger or smaller. It's just not equal to 15%. So we're going to do a two-tailed test. Step 1 is a two-tailed test. And we think our true percentage was 15%. And they're saying we don't think it's 15%. And the critical level they want us to use is 0.01. And then our test statistic here is going to be a z-test statistic. And that's going to be p hat minus p0 over the square root of P0 times 1 minus P0 over N. So our P hat, we have to calculate. They told us that X is equal to 250 out of N, because this is our P hat, or P prime is what our book uses, 2021. And that is 0.1237. So that's going to go 0.1237 minus 0.15 over, and then remember, this is our P0, so we're going to use the 0.15 here, 0.85 over N, we said was 2021. And we're going to let Desmos calculate this. Oops, this is my equal sign. Okay. And then we're going to draw a picture for our step 4. Show you that. And because it's a two-tailed, we're going to have p-value on the left, and we're going to have some p-value on the right. And we're going to compare our p-value in step 5 to our alpha of 0.01. And then we're going to draw our conclusion. So let's go to Desmos for that. And we're going to choose the one that's for proportions. And so our sample was 2021. And our P from our sample is 0.1237. And we think it's 0.15 was our original thinking. And we have don't worry, it looks like it's something different, but it's really not. And our alpha, which we don't have to put in here anyway, that really the alpha is only needs to be entered when you're doing a confidence interval. But our z-score is a negative 3.31. And our p-value is quite small. Oops, and we're going to choose, we're choosing the not equal to down here, which you should actually just choose equal to. That's what we're checking. So our z-score is a negative 3.31, and it's very small, 0.00009. So 0.000929. Let's go back to our paper so we can write this out. So I put my z-score over here, a negative 3.31, my p-value, which is very small because our z, we're very far from the mean, right? We're actually over here is our z, which is a negative 3.31. So we're definitely in the danger zone. And it's less than alpha, so we do reject H0. So there is sufficient evidence. Evidence to support the claim that the percentage or proportion of people who are self-employed is not 15%. So we don't know what it is. We can't say it's the 12.37% from our sample, but we just have enough evidence to say that it's not the 15%. We do have that. Okay, let's move to question 3. It says, in a survey of 444 random HIV positive smokers, 170 reported that they had used a nicotine patch to try to quit smoking. Can you conclude that a minority of HIV positive smokers have used a nicotine patch? Use 0.05 as our level of significance. And then A says, assume that there are 200,000 HIV positive smokers in the US. Verify the conditions for conducting this hypothesis test are met. Give explanations with context. So we have to decide what kind of data we have here. Are we talking about proportion? Or are we talking about average, something quantitative? I think we're talking about proportions. For one, they said minority. And so minority would mean that less than 50% or less than 0.5. I started to write that. So less than 0.5, that's a minority. A majority means more than 50%. So we're definitely talking about proportions. So we're going to use the same, basically the same page in our formula sheet that we used in the last problem. It's going to be this one. But this time it's a left tail because it said minority. And so that's going to be down here. So let's just write our hypothesis statement, and then we're going to go up and verify our conditions. So our hypothesis statement is P is equal to 50%, because minority says that we're going to base it on the 50%, and they're proposing that it's less than 50%. So we need to verify our conditions. So the first condition, going off our sheet, is that we have a random sample. So they did say that we had a random sample of people in a survey here. Random HIV positive smokers. Okay, number 2 says we have to show that it's smaller than 5% of the population, our sample. So our sample N is equal to 444. And is that less than 5%? They said that we know our population size is 200,000. And we can show that 444 is that less than 0.05 times 200,000, which would be 10,000. So yes, we can show independence that way because we're not using replacement. So that's why we have to show this. And then the third thing is our normality. And our normality here, confidence intervals are just a little bit different. But in normality, it's the same formula, but we're using the P0. So make sure that we're using the 0.5 here. So N is 444 times P0, which is 0.5 times 1 minus P0, which is 0.5. So 0.5 times 0.5 times 444 is 111, which is definitely bigger than 10, so we're good to go. Okay. So step 2, we already wrote out our hypothesis statement. So step 2 is our level of significance, which they said was alpha 0.05 this time. And our critical Z value, which we're going to get from Desmos. We do need to know our P hat though, which is X divided by N. And we said that was 170 out of the 444 people sampled. And so that comes out to be 0.383. And so we're going to put that information in and we'll validate that we get this. And it's a less than, so our p-value is going to be on the left this time. And so in step 5, we're going to use our p-value, which is going to be right there, to compare to alpha of 0.05. So our z is that calculation of p hat minus p0 over our standard error of p0, 1 minus p0 over n. So we have 0.383 Whoops, no, sorry, subtracting 0.5 over 0.5 times 0.5 over 444. It's not supposed to be a parenthesis. So let's go to Desmos, and Desmos is going to calculate it for us. Okay, so we're going to go back up, and our sample size here is 444. Our P that we found is 0.383, and we think it's really 0.5, 50%, but we're contesting that it's a less than. And because we're doing a confidence interval, we have to enter our alpha, which is 0.05. And then we're gonna go down. We're not doing a confidence interval because we're doing a less than. Sorry, we don't need our alpha, but we put it in. We're doing a less than hypothesis test. So I'm going to click on that drop down here. And it is very small. And you can see that because our proportion, our z-score is way past our mean, negative 4.9 standard deviations below. Wow. So yes, our p-value is very, very, very small. So it's 0.0000000, so 6 zeros and 409. So yes, definitely unlikely. So we are going to go back to our paper for a moment. And very, very small. So yes, we do reject H0. So there is sufficient evidence to support the claim that a minority of HIV positive smokers have used the nicotine patch. I'm not sure what being HIV positive has to do with smoking and using a nicotine patch, but that's just who they were gathering information on. Hopefully you're getting the hang of these hypothesis tests. Okay. Question 4. It says, when testing a new drug, scientists measure the amount of active ingredient that is absorbed by the body. So measure an amount. So I'm thinking it might be quantitative. In a study done at the Colorado School of Mines, a new antifungal medication that was designed to be applied to the skin was tested. The medication was applied to the skin of 8 random adult subjects. And equals 8, okay. 1 hour later, the amount of active ingredient that had been absorbed into the skin was measured for each subject. The results in micrograms were as in the table below. So there they are. So is something measured? So we're going to call it means because it's quantitative data. We need to measure, verify that our conditions have been met. So they did take a sample, was random. 8 random adults. There we go. And then we need to show independence. So our sample of 8 is definitely less than 5% of all adults, all US adults, right? Okay. And then the third thing is normality. And because we have a sample size that's less than 30, we have to use the normal curve. So the normal curve looks fairly linear. I made those 2 dots there on accident. So normal, oops, plot looks linear. So check, and that's this our normal plot right here. Okay, so our hypothesis statement. What did they say it was? 1 hour later, the amount of action ingredients. Okay, let's see if it says it on here. Conduct the hypothesis test to determine whether the amount observed is different, okay, than 2 micrograms. Okay, it says use Gaskell method. We're going to use the p-value method. 2 micrograms. Okay, so different than is a not equal to, so it's going to be a two-tailed, and we are using the test for means. So we have to flip back to this page for a population mean. So and you can tell because our hypothesis test should be using the population symbol of mu for mean. So this is going to be our hypothesis statement. So H0 is the mean is equal to 2. H1 is the mean is not equal to 2. And we're going to test at an alpha of 0.05 up here, 0.05. And so we're going to have a critical T value that's going to come out of Desmos. And so we need to go to Desmos and put in our raw data. We need to get from Desmos our sample mean and our sample standard deviation from Desmos. Okay, so let's go do that first. Enter our data into Desmos. And I am just going to open up another one here so I can have my data in. And so we had 1.28. So go ahead and enter in your data and validate that you've typed it correctly. And 3.86. I just have them out of order here. Okay, so we're going to do the mean of x1 and then the standard deviation of x1. So our sample mean is 2.53. And then our sample standard deviation 0.917. And while we have this up, I'm just going to go ahead and open up our means and our Desmos link and go in and enter our data. So our sample size was 8. It's small. Our sample mean was 2.53. Our sample standard deviation was 0.91. Oopsie. 7. And we're comparing that to our population mean is 2. So our t-score is 1.63, which doesn't seem very far above the mean. So 1.63 standard deviation. So we'll see what, so we're going to go to our not equal to, which is an equal to in, it's the third choice here for the p-value. And then we're going to scroll down and our p-value is 0.146. Okay, so let's write that down on our sheet. Our p-value is 0.146. Go back to our paper here. And there's our t-score, our p-value that's associated with that, and our alpha 0.05. And it's a two-tailed, so we've got a little bit over here and a little bit over here. And it's spread between the two. And it is greater than, so we do not reject H0. Definitely not going to be able to say that is true. So there is not sufficient evidence to support the claim that the medication that the amount of medication absorbed through the skin is anything different than 2 micrograms. Not enough information to say that. So reach out if you have any other questions. D4 class.